Thanks, Adam. Pleasure to be along and contributing. So I'm a technical director in the AECOM Building and Places team here in Melbourne. I lead parametric and timber design initiatives, as well as I tend to do more unusual and design-focused projects is my passion. My focus recently, however, has been on mass timber office buildings, and thus the discussion today. In terms of my background, I'm originally from New Zealand. I did a seismic engineering degree at Canterbury University, and actually marked third pro timber engineering papers for timber engineering for Andy Buchanan back in the day, which a lot of listeners will know who Andy is. So I started doing large-scale timber townhouse developments when I first graduated in Auckland, but in amongst a lot of steel design. I then worked overseas for quite a number of years, Norway, London, Hong Kong, and the Middle East, before beaching up in Australia about 10 years ago. And a lot of that work overseas wasn't actually in timber, it was more around freeform long span structures. But when I moved back to Australia, I certainly got drawn back to timber, as I think it's like a really exciting material to be involved in at this time. My father's actually a quantitative geneticist who's a bit of a world expert on Pinus radiata tree breeding, so there's a bit of it in the family. But I just feel like, there's a lot of very exciting architectural design being done in timber at the moment, which really interests me. And it's extremely interesting from an engineering perspective. There's a lot of mass timber still relatively novel at the large scale that we're looking at it now, and the problem solving and research is really exciting. So, in terms of the projects I've worked on, one of the first projects in Australia since coming back was Swinburne Factories of the Future, which was a cylindrical plywood ball meeting room and a high digital technology laboratory for Swinburne, which was a fantastic little job. Wesley Learning Residence dining hall roof with Cox Architects, so express timber trusses. Probably my most well-known project, the Bunjil Place grid shell, which is obviously a bit of a landmark piece of timber architecture in the Australian context, and it married my interest between freeform geometry and timber together. So it was a dream project. And in terms of office and more conventional structures, which we'll be talking about today, I've led multidisciplinary AECOM teams on Ballarat Gov Hub, which is a 5-storey mass timber building in Ballarat, about 15,000 square metres of office, which has been completed with John Wardle Architects. Obviously a massive learning curve going through that, and a lot of the learnings I have, taken from that project. We've also done a lot of work with the American developer Hines on timber scheme for a commercial building in Richmond, but also we're doing 36 Wellington Street, which is a 14-storey building in Collingwood, currently under construction. So super exciting. So there's a bit of a snapshot. Yep.
Yeah, well, it's a lot of experience, and we had Andy Buchanan on the podcast as well, and so I'm guessing, Andy being a fire or structural engineer, but close look on fire, I understand you've also across multidisciplinary understanding. So why is timber preferred for these commercial office buildings? So putting the client's hat in, what are their drivers that you need to keep in mind when you're doing the early concept designs?
Well, I think, the sustainability story is really a big one now, and certainly we're finding clients are becoming a lot more sophisticated about that. And with the current climate emergency, obviously timber, fits that really, really well. The fact that we're essentially locking carbon into the building rather than emitting it is a massive benefit at this moment in time when we're so desperately wanting to reduce greenhouse gases. And obviously, there's a challenge that needs to be looked at the end of life, but really, we now have time to deal with that and become more sophisticated. And, a lot of our clients are really, that is a big driver for them now. In terms of structural engineering, the reduced weight of timber can be a real benefit, either with poor soils, sites with loading constraints that we looked at one recently with a rail corridor under it and actually limiting the weight of the building, or vertical building extensions, trying to get as many levels on a building as light as possible. All those things timber suits very well for. I guess there's also a sense that a lot of our clients perceive that it's a premium product, showing off the timber. People love being in a timber space, so better return on commercial rentals is certainly something that we're hearing from our clients that they're able to achieve with the sort of biophilic wellness of tenants, as well as tenants having sort of more sophisticated, internal processes and corporate requirements relating to ESG themselves. And then, just from a construction perspective, it's a really nice product to work with. And, as the builders are now coming through their first couple of projects and they're getting, more used to timber, the benefits of it are beginning to show through. The high tolerance and prefabrication is beneficial, less truck movements on the site, accelerated program. A lot of those things are hard to fully realize necessarily on your first project if you're a builder, but once you're getting a roll on, I think these benefits are really beginning to be seen a bit more now. So.
Yeah, well, there's a load of benefits you went through there, and no doubt there are some things we compromise on when it comes to, say, traditional concrete construction. And perhaps the big question is always, what are the grids you can work with mass timber? So what do you think in terms of grids are most appropriate for design, manufacture, and perhaps assembly as well, for any architects listening?
Yeah, so there's a couple of ways of cutting it, and I guess with the buildings that we've looked at, we've gone sort of one of two ways. A 6 metre span on the CLT between primary grids is generally a pretty efficient one for timber. You get 6 metre span, you can get a 12 metre panel, you get a double span, which helps for things like progressive collapse and structural requirements. But it's also a pretty efficient span in terms of minimising the mass of timber in the floor. The reality is a lot of the mass of timber in a project is related to the floor thickness. And that 6 metre span works pretty well. In terms of the primary span, sort of 9 to 10.5 metres seems to be sort of the sweet spot at the moment that we're seeing in terms of working with floor to floor heights. In a commercial building, most clients are not wanting a 4.1, 4 metre floor to floor. We're seeing a lot of our clients are wanting, 3.8, 3.75, and are really wanting to squeeze the floor to floors. So you've got to juggle that balance between the economy, the vibration performance, which typically is what governs. It's not normally strength or deflection or even necessarily the fire performance. It's often vibration we find that's what's driving the design. And also it's mechanical distribution as well. We need to get the surfaces around the floor plate. So we're finding that sort of 9.5, 10 by 6 is a very efficient way of doing it. However, it does raise some challenges with mechanical distribution that just need to be worked through with the team. Alternately, Ballarat GovHub was a 9 by 9 solution, which is approaching something that's more akin to a conventional concrete scheme, I guess, with the introduction of secondaries. And that is absolutely possible. It just, you need to work through the volumes of timber and looking at minimizing the number of connections, for example, and things like to achieve that 9 metre span, typically secondary beams are being adopted. Things like cassettes were often looked at a year or so ago, but don't seem to have really got a lot of traction in terms of cost and viability. And then I guess beyond that, we're going to be increasingly looking at hybrid sort of solutions between steel and concrete, I think. And, you've got organisations like Verity out of Sydney looking at composite systems with CLT soffits, with metal tray floor systems, and mixing concrete and timber to achieve greater spans, which I think will allow you to sort of sit somewhere in between those two grids, most probably, or pushing back towards the 9x9. So, I think, somewhere between the 9x9 and the 9x6 is sort of generally where we're sitting at the moment, but at the same time, the systems are moving ahead all the time.
You've touched on mechanical services. You've touched on what's most efficient structurally. What about acoustics? Where does this sit in the multidisciplinary look at commercial office buildings?
So I guess commercial office has a less onerous requirement than residential, which is an advantage with timber. And really, it's a little bit up to the client in terms of the discretion, in terms of the acoustic performance they're after. Whilst residential is typically governed by the BCA and has quite rigorous requirements for obvious reasons. If you're sleeping in bed at night, you want to know that you don't want to be hearing the neighbours. In an office, generally there's AAAC, which is the Association of Australian Acoustic Consultants. They have guidelines for achieving acoustic performance, which are industry standard, but they're also been established off a historical background of concrete structures. And the reality is concrete structures give you a high degree of acoustic performance for free, but it doesn't necessarily mean that those thresholds are required. The reality is lower performance, what we're seeing is probably adequate. But in saying that, what we do aim for with acoustic performance is to achieve those same benchmarks at the moment. And we're also seeing Green Star, also some acoustic requirements coming in on that. So you've got, internal reverberation is one thing within the spaces. And obviously if you have exposed hard surfaces of timber, that just needs to be looked at. And we found on Ballarat GovHub, we had call centre applications, for example, not a standard office, which had more onerous acoustic requirements, which required sort of acoustic panelling or fins to address that. However, your average office can generally be demonstrated to work from that. In terms of the actual floor-to-floor performance, structural borne noise comes in two forms, really, like heel drop from the noise before or airborne noise coming through the floor plate. And the way of addressing that is typically through a raised floor system for office buildings we're seeing at the moment. The raised floor achieves a range of things very effectively. It allows you to distribute the electrics through the floor, which is desirable without sort of unsightly umbilicals through the floor plate. But it creates a layer which aids fire performance, and it really addresses the acoustics in one hit as well. And the final thing is, in terms of actual flatness of the floor, it also means you don't need to be worrying about that with the timber finish as well. So we're really seeing the majority of our clients are running with a raised floor, which, the build-up is typically some sort of a cementitious tile. You've got the raised floor system, generally between 90 and 120 mils of depth, sitting on some resilient pads, which helps dissipate the impact noise, then insulation in that cavity, and then you've got normally sort of 120 to 200 mils of CLT, depending on the structural system you've selected. North America, sort of concrete is a much more common way of addressing that, but that's generally been resisted in the market here with respect to trying to avoid sort of the wet trade and the additional weight that comes with it. And the reality is, with the raised floors, it really typically addresses all these issues.
Fantastic. There was a lot of gold in that one. And finally, the other key multidisciplinary item is, of course, fire. What are the critical items to address here, and how does architects, get the most exposed timber that's obviously doesn't impact fuel loads too much?
Yeah, look, the fire requirements for a mass timber building in part really depend on the height of the building in the first instance. And that's, in practical terms, that's related to sort of the ease of firefighting and also a sort of a perception of risk. The higher the building, the higher the level of risk. So, depending on where you are in Australia, the local fire authority will have slightly different interpretations on what they are willing to accept. And, in Victoria, for example, where we are, it's probably one of the tighter jurisdictions. But in high level terms, if you're under 25 meters, there is a sort of an arbitrary height there that you're likely to be subject to significantly less scrutiny. And that sort of comes back to, again, the ability to firefight on a lower building and a perception of lower risk. And, there's been beneficial factors which can aid negotiations with the fire authority as well, like, looking at whether they can actually firefight from all four sides rather than simply from one side of the street, or whether the lifts are actually constructed potentially in concrete to give the fire department a sort of a warm feeling inside in terms of being able to firefight in a non-combustible cavity. So there's sort of there's a degree of give and take there is what we find at the moment, negotiating with the fire department. For taller buildings, you really need to have early engagement with the fire authority, and you need to be down there communicating to them what your aspirations are and have a strategy for doing that. We've found an effective means of doing that is looking at Regulation 129 items, which are fire engineering non-compliances, and trying to keep that as deemed to satisfy as possible. The fire department gets referenced when there are non-compliances or non-performance solutions, and if you remove those non-compliances, it certainly paves the way to possibly more fruitful negotiations in terms of what you can achieve. And again, just things like a concrete core we've adopted in the past as a quid pro quo. I typically have the attitude that I don't try to be too purist about making everything timber. My objective is to do the right solution for the project. And if it means implementing, some conventional elements of construction while doing my best to maximize the timber, then, that's probably, the best way forward. And I guess other things that may be considered are whether for taller buildings, concealing the soffit. A lot of the discussions are around the quantum of combustible material on every level, because the structure itself is combustible, and encapsulating soffits greatly reduces that. So you can still, for example, have all the post and beam system exposed, which is a lot of what people experience in the spaces. That's been a tool that we've adopted in the past. And I guess early definition of the fire testing requirements is really vital as well. So planning right from inception on the project about what your detailing is likely to look like, planning through the fire testing, ensuring that gets included in the tender documents very explicitly and programmed in through. So, that's a very effective way of, planning right from project inception to ensure that that finds its way through the project.
So what as we're getting toward the end of the interview, what are some of the major items that we haven't really covered that are really key to make projects successful?
I think an experienced project team is really important at this stage of events. There is really probably no need right now to have an inexperienced project team on a project. I think there's no issues with having parts of the project team that are maybe, undertaking the design for the first time and upskilling. And I think that's important in terms of developing the expertise in the market. But you need to have, a number of key players in the team that have points on the board, I think. The fire engineer is a very important one. I think building surveyor again, and ensuring there's early building surveyor engagement is really important. We have found that an integrated engineering offering is particularly well suited for timber, and as an integrated firm, I don't think it's necessarily always done well in the industry. People sell a fully integrated offering and it's not necessarily well joined up. But I found from our experience, I think we've really found that timber is one that it works extremely well for the reasons that everything needs to get coordinated together through the process. I think engagement with the fire department, as I referred to earlier, right from the outset, is really clear, and having a really clear strategy as a team on how that will be planned throughout the project. Early coordination is a really major one, and I've seen examples in the market where people have started designing the building at scheme design, and the structural engineers have done a scheme, and the mechanical engineers have done a scheme. In a normal sense, they've done them independently of one another. The building's gone to town planning, and then you find yourself coming to, when those two disciplines come together, you say, well, how does the mechanical ducting find its way across the floor plate? And you can penetrate beams and things like that, but it's not necessarily the most efficient way of doing it, and you can sort of paint yourself into a corner a little bit. So I really think a team that is heavily engaged right early in the process and developing the scheme in an integrated way. I have literally schemed structural floor plates while drawing the mechanical ducting myself, and then had my mechanical engineers critique me and tell me I don't know what I'm talking about. But literally, the solution was developed hand in hand, and that is not a standard design process in the market at the moment, and you need a team that's going to think in that way, and you can get really successful outcomes, I think. I think digital is really well suited to timber. Again, that early process, we often do full 3D modeling and SketchUp and Revit between structures and mechanical at that concept design phase, and we can show the client spatially what their timber floor plate's going to look like. And I think we find clients respond really well to that, and architects as well. And I guess procurement route is a really important one as well. You need to understand how you're going to get this timber, what the design responsibilities are as you move through the process. We have, done it a number of different ways, and we have fully documented all the way through a number of times as well. But I think, we're certainly finding that early contractor involvement has been pretty successful on a number of projects recently. If it's done well, having the builder at the table sort of, as the design comes together, and being able to leverage the timber specialists, specialist contractors, their expertise really de-risks the process. You can get the jump on the fire testing, and you come through that tender, you've got a lot more cost certainty. And we think that, we've found that to be a very effective means of, developing the design.
You've touched on a few things already, like digital design, but what do you see as the future of timber structures and some of those cutting edge sort of innovations? And, where's that going to lead everything, do you think?
Yeah, I guess there's a degree of cutting edge and a degree of incremental progression. I think, the fire engineering is a really key one, and, there's an enormous amount of work happening all the time on that, and we're really progressing. And I think what we'll begin to see is that arrangements become tested and acknowledged as working, which is going to reduce the burden of fire testing on every project. And also, I think we're going to get to a point where there's a lot more consistency and greater certainty on where the authorities are sitting on these things, which is just going to increasingly streamline the process. Similarly, the local supply chain has come so far in the last 3-4 years, and we're already at the stage where we've got really, mature, credible organisations producing timber locally. That's simply going to develop further, and there's going to be more and more consultants capable of actually undertaking the design. In terms of tall buildings, I'm not sure that we understand what the sweet spot is in terms of timber, in terms of height of buildings. The sky is the limit, but at the same time, you need to understand where the sweet spot is for the material. And, there's a lot of interesting work looking at sort of hybrid approaches to that. So I think that's going to be really interesting to see, where we perceive the sweet spot for timber to be in terms of the height of buildings. Certainly, a Wellington Street building, it's got 9 levels on 6 levels of concrete. I think that's absolutely no problem. It's a no-brainer, 9 levels of timber. When we start talking 30, 40 levels, it's going to be really interesting just to see how those sort of hybrid approaches settle down and how that really, stacks up in terms of how the material sits. I think I'd like to see probably a bit more sophistication in design with a view on adaptive reuse. Designing a solution that absolutely clicks and works is fine, but we still need to make sure that we've got a view on how the building will be flexible in the future. And I think there's just a bit of maturity that will come forth as that works through. I certainly think digitally we will be progressing towards consultants now modeling with a view to handing that digital information more. There's going to be more of a linkage between the builders and the consultants, and this sort of very old school approach of it being quite separate is going to develop, I think, in terms of a more seamless transition between, the early design phases and the fabrication and the use of that. And I think, just in general, sort of coming back to hybrid structures, I think we're going to see a lot of people looking at how to make timber floor systems such that, these the buildings are as flexible as possible. So these hybrid solutions that sort of Ready and a number of other organisations are looking at, I think, are increasingly going to come into the market. A lot of these need some physical testing to demonstrate their performance. And I think in the next couple of years we're going to see more and more of that coming through, which makes a lot of sense to me.
Well, it's such an exciting future, Nigel, and it's been a pleasure having you on the podcast. If people want to find out more about yourself and AECOM, and where should they go?
You can send me an email to nigel.burdon@acom.com. I'd love to hear from you.